Simplifying radicals. So in this section what we're going to do is we're going to learn how to reduce and do some math with the radicals. So the first thing we're going to do is talk about the product rule. Product means to multiply. So the product rule for radicals, basically it says if the square root of a and the square root of b are real numbers, then the square root of a times b can be broken out to the square root of a times the square root of b. These two mean the exact same thing. I can go from here to here, and I can go from here to here. So these are equivalent. So in order to simplify a radical, I'm going to use the product rule. And in the product rule for the first one, what we're going to do is we're going to try to find a perfect square, because I'm dealing with square roots. So I'm going to try to find a perfect square that will go into 40. And we're going to break it up into its product. So 4 is a perfect square times the square root of 10. So what you want to do is you want to break your radicand into a perfect square factor times its other factor. So I know that the square root of 4, I know 4 is a perfect square, and I know 4 times 10 is going to give me 40. So then what I can do is I can actually take the square root of 4 and get 2. I cannot take the square root of 10, and so therefore I get 2 times the square root of 10. Now, something that may help you until you get used to doing this is actually writing down all of your perfect squares. So your first one that we're going to use for our purposes is going to be 4, because 2 times 2 is 4, and then the next one's going to be 9, because 3 times 3 is 9, and then 4 times 4, so the next one's going to be 16. 5 times 5 is going to be 25. 6 times 6 is going to be 36. 7 times 7 is going to be 49. 8 times 8 is going to be 64. 9 times 9 is going to be 81. 10 times 10 is going to be 100. 11 times 11 is 121. 12 times 12 is 144. And this goes on and on and on. Okay? So keep this list on your mind or write it down somewhere until you get used to doing these, because what we're going to do is we're going to break these radicands into the biggest perfect square factor times its other factor. And then we're going to take the square root of the perfect square and bring that out of the radical, and then leave whatever's left over under the radical. So let's look at this one. You have the square root of 300. Well, I know the biggest perfect square that will go into 300 is 100. So I'm going to write that down. Square root of 100. I know 100 will go into 300, and I know it'll go 3 times. So 100 times 3 is 300. So now to further simplify this, the square root of 100 is going to be 10. I cannot take the square root of 3, so the simplified answer is 10 square roots of 3. Alright, 15. So 4 won't go into 15, 9 won't go into 15, and obviously anything else wouldn't go into 15. So for letter C, this is simplified. So the square root of 15 is equal to the square root of 15. It will not simplify. Alright, let's try this one. So now we have a coefficient out here to the left. So this says 7 times the square root of 75. 7 times the square root of 75. So what I need to do is I need to break 75 down into its perfect square factor, which is going to be 25. That's the biggest perfect square that will go into 75, times 3. So what I have is 7 times the square root of 25 times the square root of 3. Well, I can't do anything with the 7. Square root of 25 is 5, and I can't do anything with the square root of 3. So now if I do the multiplication, I'm going to get 35 square root of 3. Alright, so let's talk about the quotient rule. Same thing. If a and b are real numbers, and of course b cannot be 0 because we're talking about fractions, so your denominator cannot be 0. The square root of a over b is the same thing as the square root of a over the square root of b. So just like you can break something into its multiplication factors, you can also break something into its quotients. So let's look at this one. First thing I want you to look at is the fact that 5 over 16 will not reduce. That's where I want you to go first, okay? If the fraction underneath the radical will reduce, then I would prefer that you go ahead and reduce it. But when it won't reduce, what you're going to do is you're going to break it up into the square root of 5 over the square root of 16. And then the square root of 5 we can't do anything with, so that is the square root of 5. And then the square root of 16 is going to be 4, and so that is simplified. So with letter B, 40 over 81, that will not reduce. They don't have anything that will divide into both of those. So what we're going to do is we're going to break out the square root of 40 over the square root of 81. Now, the square root of 40, we've already done that. We know that the square root of 40 will break down into 4 times 10. And we also know that the square root of 81 is simply 9. So let's keep going farther. The square root of 4 is going to be 2 times the square root of 10 you can't do anything with over 9. So that's your simplified answer. So what you're trying to do is you're trying to bring out as many perfect squares as you can out of that radical. Alright, simplifying variables. So assume that all variable expressions represent positive numbers, and we do that, we state that simply because you know you can't take the square root of a negative number. But remember what we were talking about. If my index is 2 and I have variables, what I'm going to do is I'm going to divide 7 by 2. Well, if I divide 7 by 2, and let's go back and do like elementary algebra. So we'll say 2 will go into 7. 2 will go into 7 3 times. Multiply around and we're going to get 6. And we're subtracting, we get 1 left over. So I can bring 3 x's out, which means I'm going to have x cubed on the outside times the square root, and I have 1x left over, so that's going to go in here, and you can write the 1 up there if you want to, but we are talking about exponents, so keep that in mind. Okay, so what about the square root of 20? So the square root of 20 will break into, the biggest perfect square that'll go into 20 is going to be 4, and we're going to multiply that times 5 to get the 20. And then here we're going to take the square root of x to the 16th, so break them up. So the square root of 4 is going to be 2. You can't do anything with the square root of 5. And then the square root of 16, remember the index is 2, so we're going to do 16 divided by 2, which is going to be 8. Okay? So that's how you're going to deal with those variables. Alright, so let's deal with some cube roots. So when we talk about cube roots, we're going to go to a different list. So previously, how I wrote down the square root, or the square list, the perfect square list, now what I'm going to do is I'm going to write down the perfect cube list. So let's start with 2's. 2 times 2 times 2 is going to be 8, so 8 is your first perfect cube. 3 times 3 times 3 is going to be 27. 4 times 4 times 4 is going to be 64. And then 5 times 5 times 5 is 125. And then 6 times 6 times 6, I need to do the calculator on that one because I don't know what it is. 6 times 6 times 6 is going to be 216. And 7 times 7 times 7 is going to be 343. And so that goes on and on and on. Okay, so we're going to treat the cube roots the same way we do with the square roots, except we're going to use a different list. We're going to use the perfect cube list because my index is 3. So now 16 is my radicand. So I've got to look up here and see what is the biggest perfect cube that will go into 16. And I think it's 8. And so I'm going to break it down. Now don't forget your index. You have to write an index if it's an index higher than 2. So we're going to do the cube root of 8 times the cube root of 2. And the cube root of 8 is 2, so I get 2, and I can't do anything with the cube root of 2. You can't take the cube root of 2. Okay, same thing with your division. Again, these will not reduce. 3 and 64 will not reduce. So what I'm going to do is I'm going to break them up. So I'm going to do the cube root of 3 over the cube root of 64, and 64 is a perfect cube, but remember what number we multiplied times itself 3 times in order to get there, and that's going to be 4. And the reason why I say that is a lot of people who know the square root list want to put an 8 here, but it's not 8, it's 4, because 4 times 4 times 4 is 64.